Hello everyone, welcome to Abhyaas IIT Prep channel. I am Dr. Karthikeya. In this video, we are going to discuss 2024 JEE Mains Physics Thermal Properties of Matter questions. To solve the thermal properties of questions, we need to understand what is meant by heat, calorimetry, thermal expansion, what is thermal expansion, and also what is conduction, convection and radiation. So how to solve the problems? So we need to understand application of these different concepts in various problems. Okay, hardly we have 5 questions related to this particular thermal properties of matter. This topic comes under properties of solids and fluids actually in the NTA syllabus related to JEE Mains 2024 physics or to physics topic, physics. Now directly we are going to thermal properties of matter. Okay, so in this session we are discussing questions related to different 2 phases, that is January phase and also April phase. We have 5 questions. We'll start with January phase initially, then we'll go for the April phase. Okay, series. So in the first question we have an ice at 10 degrees centigrade, minus 10 degrees centigrade, and it is heated gradually and finally it is converted to steam at 100 degrees centigrade. By seeing that, so what happens? Initially the temperature is increasing, heat is given. So temperature is increasing from the minus 10 degrees centigrade. Then it gone to 0, then it gone to 100. So what happened initially from the change of minus 10 to 0, so this is the temperature axis, this is heat supply. From minus 10 to 0, we need to give heat. So you just take point like this. At 0 degrees centigrade, we are continuously giving heat, but change of state has to happen. Okay. Next, after this one, you need to give continuously heat. It has to change from 0 to 100. So after this, we need to continuously give. So this is ice stage. This is ice to water conversion. Next, water to steam. Okay, water to steam conversion at 100 degrees centigrade. That's why this is the curve. So A is the option. So continuously we are giving heat and change of state has to happen from ice to steam. So from ice to water it will convert. When minus 10 to 0 degrees centigrade happens, ice will gradually gets heat, and at 0 degrees centigrade ice converts to water. So after from 0 degrees centigrade to 100 degrees centigrade water will be there, but we are giving continuously heat, so it will increase its temperature gradually. At 100 degrees centigrade what happens? It will convert, that water converts to steam gradually, so it will come to vaporized state. So finally, okay, that will happen. Okay, so after that if you give the temperature it will vaporize more. Okay, so going to the next question. So here what happened? Combination of this one, resistance. So yeah, initially we have 2 conductors, combination of conductors, this is the thing. So he is given 2 things, temperature coefficients, 2 resistance are there. Yeah, okay. So first of all, if you try to do series then parallel. So in series what happen? R equivalent is equal to R1 plus R2. But what is R equivalent in series? That is 2R. 2R into 1 plus alpha equivalent delta T, that is there. R1 is R into 1 plus alpha into 1 into T plus R into 1 plus alpha 2 into T. So all sides R get cancelled. What happens? 2 plus 2 alpha equivalent delta T or T. Both are okay, delta T. So everywhere delta T is equal to 1. So 2 plus alpha 1 plus alpha 2 into delta T. So then what happened? 2 to get cancelled. After that 2 alpha equivalent delta T is equal to alpha 1 plus alpha 2 delta t. Delta t get cancelled. Alpha equivalent is equal to alpha 1 plus alpha 2 by 2. So this is the in series. Similarly, in parallel, what happened? 1 by R equivalent, combination of conductors, R1 plus R2. But what happened? R equivalent in parallel is 1 by R by 2 into 1 plus alpha equivalent delta t is equal to 1 by R1 is okay, R into 1 plus alpha 1 delta t plus 1 by R into 1 plus alpha 2 delta t. R get cancelled all the way. Then 2 by 1 plus alpha equivalent delta t is equal to 1 by 1 plus alpha 1 delta t plus 1 by 1 plus alpha 2 delta t. So on doing LCM and neglecting the small quantities after multiplication, so you will get alpha equivalent equal to alpha 1 plus alpha 2 by 2. So this calculation part you just do. But finally you will get alpha 1 plus alpha 2 by 2 in both series combination and parallel combination. So option A is the correct. So only thing is, if you have to know these things, what will come in series combination, resistance, what will come in parallel combination. So this is one of the easiest question, but it is somewhat difficult when compared to the first question. First question is very easiest one. Okay. Now going to this April phase. So two questions came related to January phase. Now going to the April phase. In the April phase, we have what happened. So ice point, steam point. Ice point means 0 degrees centigrade. Steam point means 100 degrees centigrade. At ice point, that is R0 is equal to R0 means 0 degrees centigrade, 8 ohms. R100, that is steam point, is 10 ohms. So R100 is equal to R0 into 1 plus alpha delta t. Okay, delta t, 100 degrees centigrade. This is 10 is equal to 8 into 1 plus alpha into 100. So after this one, you multiply both. 2 is equal to 8 alpha into 100. So then what happened? 1 by 400. So then what he is asking? R400 he wants. R400 is equal to R0 plus 1 plus alpha delta t. Same only. What is R0? 8. 8 into 1 plus alpha 1 by 400 into temperature difference is 400. So finally this get cancelled. 8 into 2, that is 16 amperes, 16 ohms. This is the answer. Okay. Yeah, simple questions. So trying to solve in a easiest manner. So another question which is there on Celsius scale, the temperature increase is 40 degrees centigrade. That is C minus 0 by 5 is equal to F minus 32 by, that is 9. So this, if you see this C minus 0, the difference is 40 degrees. 40 by 5 is equal to, so this difference F minus 32 by 9. So this is 8 9s how much? 72 degrees centigrade. So hardly 2-3 steps only. Very easiest way of solving the questions. So the difference in Celsius degree is given. Difference in Fahrenheit you need to calculate. 72 degrees Fahrenheit. It's not this one, Fahrenheit. So this is the answer. So hardly 2 steps. This is on one of the very easiest question. So another question is also related to resistances. Okay. So here also what will happen? We got at room temperature, that is R0, if you consider room temperature, that is at 27 degrees centigrade, that is R0 if you consider, that is 50 ohms. Alpha is given, that is 2.4 into 10 power of 4 degree per degree Celsius. R62 you need to calculate. R62 is equal to 50 into 1 plus alpha delta t. Okay, 50 or 62 is what? Okay, 50 into 1 plus alpha is 2.4 into 10 power of minus 4. Delta t we need to calculate. Okay, this is 62. Okay, so then what happened? 50 minus this is delta t you can take. Okay, 62 amperes. Okay, then 50 minus 62 is 12 is equal to 62 into 50 into 50 into 62 minus 50 is 12. 50 into 2.4 into 10 power of minus 4 delta t. So then what happened? So if you multiply 50 into 2.4, that is 120 into 10 power of minus 4, 12. So if you do this, so what happened? 12 get cancelled. This one 12 into delta t, you can keep delta t equal to what you will get? 1000 degrees centigrade. What is this? T minus 27 is 1000 degrees centigrade. Okay, he has given in degrees centigrade, that's why I have taken. T is equal to 1027 degrees centigrade. This is the answer. So you just see, at 62 amperes, what is the temperature he asked? Okay, so this is also one of the easiest questions. So most of the questions what we got is related to combination questions, only one question, and other things are related to this one. Okay, combination of the things, and rest is, that means rest is in series and parallel we got. Other questions are related to mostly thermal expansion questions. Okay, I hope you enjoyed the video. So thank you, all the best.